Hello students, welcome you once again to GK's maths classes. Today in continuation with this chapter on relations and functions, we are going to do problems related to relations. Okay. Already in part 1 of this video, we have talked about what are the different types of relation, what is a relation, what are the different types of relation, and what is an equivalence clause. And I also discussed one problem based on whatever concept we have discussed. And now I will also put the description of that video in this video so that if you have any clarification, you can always go back to that. Okay. So I hope these videos are useful to you. Kindly subscribe to my channel and also click the bell icon to get notifications. So we will straight away get into this chapter. So we are going to do more problems under this topic called relations. Let's see how it goes. Okay? Now, the first thing is, before we go, quickly I'll just introduce you once again to what is the relation is. S is a non-empty set. S is a non-empty set. S or A, you can call whatever you want. And R is a relation on S. That means R is a subset of S cross S. Right? Now, there are different types of relation. One is called reflexive. Now, what is a reflexive relation? For every A belongs to S, for every, okay, A must be related to itself. A must be related to itself. And I gave you plenty of examples on what a reflexive relation is and what is not a reflexive relation also we have discussed. Now, next is symmetric. Now, what is symmetric relation? For every A comma B belong to S, if A is related to B, then you can conclude that B is also related to A. So this is an definition of a symmetric relation. What is transitive? Transitive will be, you take three elements here, A, B and C belongs to S. If A is related to B and B is related to C, then you can conclude that A is related to C. Correct? And if the relation is reflexive, symmetric and transitive, such a relation is called equivalence relation. Okay, and in transitive I also made it clear that these two, if they are true, then this must be true. You can also have a situation where you have only this, A is related to B. You may not have B is related to C. If you have only A is related to B, then also you can conclude that it's a transitive relation. Okay. Now with that definition, let me go to the first problem. I'll discuss this question, very, very important question. It has come many times in the board exam. R is a relation, okay. R is a relation on set A, and it is defined like this. The set A is defined like this, and the relation is given by modulus of A minus B is a multiple of 4. So first let us understand what is my set A is. My set A is set of all integers between 0 to 12. So it will be from 0, 1, then you have 2, then you have 3, up to 12. This is my set A. It is a non-empty set. Like I said, no, S is a non-empty set, so A is a non-empty set. Now R is a relation on A. That means it is a relation from A to A. How it is defined as? Of course, it is a subset of A cross A. So elements in the relation will be an ordered pair. So how is it defined as? It is defined as elements of the form A comma B such that if I take difference of A and B and take modulus, it will be a multiple of 4. It will be a multiple of 4. So I just call it 4m. It will be a multiple of 4. Now how do I prove it is an equivalence relation? Actually, the question is not complete. Show that is an equivalence relation and also they have asked you to find equivalence class of 2. The simplest equivalence class. What is equivalence class? We'll discuss it today. Okay. So right now just take it for granted. Now, what is a reflexive relation? How many elements I should choose? For every A belongs to A. For every A belongs to A. Every A, that means from 0 to 12, I choose all the elements. What do you say about modulus of A minus A? Modulus of A minus A is 0, and 0 is a multiple of 4. Any 0 is a multiple of any number. So 0 in particular is multiple of 4. This implies it satisfies the definition of the relation. Therefore, you can say A comma A belongs to R. So A is related to itself. Therefore, R is reflexive. I hope this is clear to you. So R is reflexive. So we are done with reflexive relation. Let's go to symmetric. You know what is symmetric? For every A comma B belongs to set A, I have to choose two elements, A and B. If condition must be true. What is the if condition? If A is related to B. If A is related to B. That means what do you know? From the definition of relation, modulus of A minus B is a multiple of 4. Correct? Now what I will do? I will take minus outside. It will become B minus A. So what will modulus do to the minus? It will make it positive. So there is no difference between modulus of A minus B and modulus of B minus A. This shows by the definition that B comma A belongs to R. If B comma A belongs to R, we can say R is symmetric. Correct? This is symmetric. Now finally we have to talk about transitive. Now how do I discuss transitive? For transitive, how many elements I should choose? I choose 3 elements. A, B, C belongs to A. If A is related to B and B is related to C. Both are true. I am saying both are true. That means what? Modulus of A minus B is some multiple of 4, and modulus of B minus C is also some multiple of 4. Correct? Both are modulus. So you can't just add or subtract just like that, because it is not that, modulus, if you add them, it becomes mod of A minus C. No. Don't think that B and B will get cancelled, because modulus, when I take the number inside, can be positive or negative. So you can't just add like that. So what do? Get rid of the modulus. So A minus B, when you get rid of modulus, as I told you, the term inside can be negative or positive. So you write it plus or minus G. Then what is B minus C? The same logic, plus or minus 4K. Correct? Now you add them. This is 1 and this is 2. You do 1 plus 2. What is 1 plus 2? A minus B plus B minus C is plus or minus 4 into some G plus K. I don't care about this. They get cancelled. You get A minus C equal to plus or minus 4 into G plus K. Now take modulus. Plus or minus will become plus. So 4 times some element. Okay. So I don't know what it is. Just some element. So clearly you have proved that A minus C is a multiple of 4. So A comma C should belong to R. This implies R is transitive. Now if R is reflexive, R is symmetric, R is transitive, what type of relation R is? R is an equivalence relation. Clear? That finishes this problem. But there's another part called equivalence class of 2. Now, before I do for equivalence class of 2, I first want to make you understand what an equivalence class is. First, we'll try to understand what is equivalence class, understand the definition of equivalence class, then we'll try to find out what is this 2 is. Okay, it's a very, very important concept. Okay, equivalence class is a very important concept. Now, let's go to this. I have my set A. What was my set A? It was like 0, 1, 2 up to 12. And what was the relation? The relation is elements of the form A comma B such that modulus of A minus B is a multiple of 4. Correct? So now what I will do, first I'll take this number 0 and I'll write like this. This means equivalence class of 0. Equivalence class of 0 means all the elements in set A which are related to 0 satisfying this relation. All the elements of A which are in set A, okay, related to 0 and satisfying this relation. That means you choose any element here, 0 minus 0, for example 0 minus 0 should be a multiple of 4. So obviously this will have 0. You cannot have 1 because 1 minus 0 is not a multiple of 4. So it can't be an equivalence class of 0. It can't be 2. 2 minus 0 or 0 minus 2 cannot be a multiple of 4. 3 minus 0 or 0 minus 3 cannot be a multiple of 4. So obviously I should have 4 because 4 minus 0 or 0 minus 4 is a multiple of 4. Now what will be the next element? It has to be 8. Why? 8 minus 0 or 0 minus 8 is a multiple of 4. What will be the last one? 12. Correct? So the equivalence class of 0 will be 0, 4, 8 and 12. Maybe if I do one more, you'll get a better idea. Let's see what will I get for equivalence class of, let me write equivalence class of 1. Now what is equivalence class of 1? 1 minus what will be multiple of 4? 1 minus 1, which is 0, is a multiple of 4. So definitely it should have 1. 1 minus 5, which is 4, is a multiple of 4. So it should have 5. 1 minus 9, which is 8, will be a multiple of 4. 1 minus 13, but 13 is not there in the set. So the equivalence class of 1 will be 1, 5 and 9. Now let's go to the next element. What is the next element? The equivalence class of 2. What is equivalence class of 2? 2 minus what will be multiple of 2? Multiple of 4? 0. 2 obviously. Because 2 minus 2 is 0. 0 is a multiple of 4. Then it should have 6. 6 minus 2 is a multiple of 4. Then you should have 10. 10 minus 2 is a multiple of 4. Other elements not possible. Correct? So the equivalence class of 2 will be 2, 6 and 10. This is the answer for the question that we have given. Okay? But I want to write everything so that you understand what I am doing. Okay? Now let's go to equivalence class of 3. Equivalence class of 3. What is equivalence class of 3? Definitely it should have 3. And then you should have, what else will be the 8? 8 minus 3, sorry, not 8, 7. 7 minus 3 is a multiple of 4, correct? And then you should have 9, 10, 11, right? 4, 11. 11 minus 3 is 8, which is a multiple of 4. This is the equivalence class of 3. Now let's go to equivalence class of 4. Now I'll go to equivalence class of 4. What is equivalence class of 4? Definitely it should be 0. 0 minus 4 is a multiple of 4. And it should have 4. It should have 8. And it should be 12. If you subtract each one of them, it will be multiple of 4. Right? Now, what will be equivalence class of 5? Equivalence class of 5 will be 1, 5, 9. Now, what will be equivalence class of 6. It will be 2, 6 and 10. Then what is the equivalence class of 7? Equivalence class of 7 will be 3, 7 and 11. Now let's go to 8. What is equivalence class of 8? Equivalence class of 8 will be 0, 4, 8 and 12. What is equivalence class of 9? Equivalence class of 9 will be 1, 5 and 9. What is equivalence class of 10? That will be 2, 6 and 10. What is equivalence class of 11? Equivalence class of 11 will be 3, 7 and 11. What will be equivalence class of 12? The equivalence class of 12 will be 0, 4, 8 and 12. And I have exhausted all the elements. Now what exactly happens here is, I have a set. My set contains how many elements? My set contains 0 to 12 elements. Okay. So I will write 0. Okay. Then I have 4, 8, 12. Then 1, 5, 9. Then I have 2, 6, 10. Then I have 3, 7, 11. Now if I divide them like this, okay, this is equivalence class of 0, okay, and this is equivalence class of 1. This is equivalence class of 2. This is equivalence class of 3. Okay, if I combine them together, okay, I get my set A. You see this? If I put them together, I get my set A. So this is set A. So equivalence class of A are disjoint subsets of A. They are disjoint subsets of A. Say for example, you can call it A1, A2, A3 example, where if I put them together, I'll get my set A, but each one will not have anything in common. Will be null set. A2 intersection A3 will be null set. And then A1 intersection A3 will be null set. So equivalence class are disjoint subsets of A. And if you notice very carefully, after 0, 1, 2, 3, for all other numbers, the equivalence class will repeat. You can see clearly here that equivalence class of 0 is same as equivalence class of 4, is same as equivalent class of 8, is same as equivalent class of 12. So there will be absolutely repetition there. So if I talk about equivalent class of 0, that means I have talked about all of this. Then you see, if you can see clearly, equivalence class of 1 equal to equivalence class of 5 equal to equivalence class of 9. And then see this is equivalence class of 2 equal to equivalence class of 6 equal to equivalence class of 10. And finally, you see this is class 3 equal to class 7 equal to class 11. Each one, you can call this as A1, you can call this as A2, you can call this as A3, you can call this as A4. If you put all of them together, you get my set A. But individually, none of them have anything in common. That is why it's called equivalence class is nothing but disjoint subsets of A. Or you can say, in other words, the equivalence class, what it does is, it partitions the set into disjoint subsets. It partitions the entire set into disjoint subsets. Okay, so it is very important you understand the definition of an equivalence class, because it's a very, very important concept when you go to higher level mathematics. But here, for this particular question, the answers, find the equivalence class of 2. The answer is, the equivalence class of 2 is 2, 6 and 10. I hope equivalence class is clear to you. Okay. Now, I have one more question here. Is equal to. I think that you can try by yourself. It is not at all difficult. I have done for modulus. You can do for A minus, or if you want, I can do it for you. For example, you take set A, which is 0, 1, 2 up to 12. Now R is a relation. How is it defined as? Is A comma B such that A equal to B. Now what I will do is, I will reflexive relation. How do I do reflexive? For every A belongs to set A, every element is equal to itself. So obviously A comma A belongs to R, therefore R is reflexive. R is reflexive. Let's go to the next one, symmetric. For symmetric, I choose how many elements? I choose 2 elements. If A is related to B, that means what? A equal to B. Definitely you know B equal to A. If B equal to A, you know B comma A belongs to R. Therefore R is symmetric. Correct? Now for transitive. What I do for transitive? For every A comma B comma C belongs to A, if A is related to B and B is related to C, what is your conclusion? A equal to B, B equal to C implies A equal to C. This implies A is related to C. Therefore R is transitive. Is that clear? It's very, very simple. Since it is reflexive, symmetric and transitive, R is an equivalence relation. Okay? Okay, I hope you understood the previous question. Now this is something similar to the question that you did today, the first question. Modulus of A minus B is a multiple of 4. Here it is modulus of A minus B is even. When I say modulus of A minus B is even, you have to show it's a multiple of 2. Okay? Now it is very clear that you have a set A. Your set A is 1, 2, 3, 4 and 5, and he says that R is a relation on A. So R is a relation from set A to set A, and so obviously R is a subset of A cross A. Now it is defined as modulus of A minus B is even. So first I want to prove it is reflexive. Now how do I prove the relation is reflexive? For every A belongs to set A, okay, I will take modulus of A minus A. Modulus of A minus A is 0, but you know 0 is an even number. Okay, so this is even. Therefore, A is related to itself. So A comma A belongs to R. This implies R is reflexive. So that concludes the first part. Now what's the second part of the question? Symmetric. Now what is symmetric? For symmetric, I choose how many elements? I choose one element. A comma B belongs to A. I choose 2 elements. A comma B belongs to A. Now what is the initial condition? If this is true, what is this? A comma B belongs to R. That means, what do you know? Modulus of A minus B is an even number. So I call it 2n. It's a multiple of 2. Now what I will do, I'll take minus outside. You get B minus A, which is also 2n. Now modulus will make negative positive. Therefore, this modulus of B minus A will be 2n. So obviously by the definition, B comma A also belongs to R. This implies R is symmetric. I hope this is clear. Well, exactly like what you did first problem. Okay, exactly the same. Now let's go to the third one. Let's go to transitive. Here I chose one element for reflexive. Here it is two elements. For transitive, I choose three elements. What do you know? There are two conditions, and both the conditions should be true. If A comma B belongs to R, if it is true, and B comma C also related to R, this implies what? Modulus of A minus B is a multiple of 2. Modulus of B minus C is also a multiple of 2. Correct? So, as I said, we cannot add modulus directly and cancel B. So, I will just remove the modulus so that the term inside can be plus or minus 2G. You know, modulus of 2 is 2, modulus of minus 2 is 2. So, the term inside the modulus can be plus or minus. So, if you remove the modulus, you have to put plus or minus. So, what is B minus C? Plus or minus 2K. So, call this as 1 and take this as 2 and add 1 and 2. When you add 1 and 2, what do you get? A minus C equal to plus or minus 2 into G plus K. B gets cancelled. Now take modulus. So clearly modulus of A minus C is a multiple of 2. Therefore it's even. So can I say A comma C belongs to R? Therefore R is transitive. Now that R is reflexive, symmetric and transitive, R is an equivalence relation. That finishes the first part of the question. Show that R is an equivalence relation. Here R is a relation from where to where? R is a relation from A to A. It is a set A to A. That is the first part of the question. Now what is the second part of the question? Show that all the elements of 1, 3, 5 are related to each other. Okay. So second part. So let's go to the next page. So second part of the question. If I don't have space. Okay, I'll do it here. Here my new relation R is from the set 1, 3, 5 to 1, 3, 5. My relation is from 1, 3, 5 to 1, 3, 5. Whereas previously it was a relation from A to A. The first condition is from A to A. Now I am talking about relation from 1, 3, 5 to 1, 3, 5. Okay. Now, you know 1, 3, 5 is an odd number, right? It's an odd number. And you know very well, difference of two odd numbers is even. Very simple, isn't it? Difference of two odd numbers is even. 1 minus 1, 0, even. 1 minus 3, minus 2, even. 1 minus 5, minus 4, even. If you put modulus, it becomes even. So the difference of two odd numbers is even. This implies every element of 1, 3, 5 are related to each other. This is the first part of the question. That finishes this part. You see, are related to each other. Second part is over. Now, the next part is R is a relation from where to where? It will be a relation from 2, 4 to 2, 4. Clearly you see 2, 4, the numbers are even numbers. So what do you know about difference of two even numbers? The difference of two even numbers is even, correct? Therefore, what do you say? Every element of 2 comma 4 are related to each other. Correct? So that finishes this part of the question, second part. Now the last part is, I have a relation R from where to where? It is from 1, 3, 5 to 2 comma 4. Correct? So I have to, this is odd and this is even. So difference of odd and even number is not even. It's definitely not even. This implies no element of 135 is related to any element of 2 comma 4. You understand? There are actually 4 problems in this. There are 4 subdivisions in this. The first subdivision is the relation is from A to A. Second subdivision, the relation is from 135 to 135. Third subdivision is the relation is from 2 comma 4 to 2 comma 4. And the fourth subdivision is relation is from 135 to 2 comma 4. In all cases except the last, it works because it satisfies the relation condition. It's an equivalence relation. Whereas no elements of 135 is related to any element of 2 comma 4 because 135 is odd, 2 comma 4 is even. If you subtract odd number with even number, you will not get an even number. So it does not satisfy the definition of your relation. So definitely it's not a relation. Is that clear? Now let's go to the next question. Show that the relation are defined on the set A. What is set A? Here I am defining my set A as set of all triangles. Okay, a set of all triangles. Now how is the relation defined as? The relation R is defined as, if I have 2 triangles T1 and T2, T1 is similar to T2. And what I want to prove, I have to prove it's an equivalence relation. I think it's very, very simple, right? So reflexive. You can do it by yourself actually. For every T1 belongs to set A, you know every triangle is similar to itself, correct? Every triangle is similar to itself. Okay? Therefore, it satisfies the definition. So T1 comma T1 belongs to R. Therefore, R is what? R is reflexive. Now let's go to symmetric. Now for symmetric, for every T1 comma T2 belongs to A, what do you know? If T1 is related to T2, that means what? That means triangle 1 is similar to triangle 2. If triangle 1 is similar to triangle 2, triangle 2 will obviously be similar to triangle 1. This implies T2 comma T1 belongs to R. Therefore, R is symmetric. Simple, isn't it? Now let's go to transitive. How many elements I should choose? I will choose 3 triangles, T1, T2, T3 belongs to A. If this is true, T1 and T2 are related and T2 and T3 are related. That means what do you know? That means you know triangle 1 is similar to triangle 2 and triangle 2 is similar to triangle 3. Obviously, you know triangle 1 will be similar to triangle 3. This implies T1 comma T3 belongs to R. Therefore, R is transitive. If R is reflexive, symmetric and transitive, what type of relation is R? R is an equivalence relation. But there is some other subdivision also attached with that. What is that? Consider right angle triangle T1 with sides 3, 4 and 5, and T2 with sides 5, 12 and 13, and T3 with sides 6, 8 and 10. Which among these triangles are related to each other? We are using the properties of similarity. Let us see which sides are proportional. Clearly you can see 3 by 6 equal to 4 by 8 equal to 5 by 10. So triangle 1 is similar to triangle 3. But clearly you can see triangle 1 is not similar to triangle 2, because the sides are not proportional. And you can also see triangle 2 is not similar to triangle 3 because the sides are not proportional. Whereas if you take T1 and T3, the sides are proportional. 3 by 6 is equal to 4 by 8 is equal to 5 by 10. So that's the last part of the question. So which triangle among them are related? So here T1 and T3 are related. T1 and T2 are not related. T2 and T3 are not related. But T1 and T3 are related. Is that clear? Now let's go to the next one. Now what is this question? Show that the relation defined on a set A. What is my set A? Set of all polygons. Polygons means it can be starting from triangle to quadrilateral to pentagon, it can be any size. Okay, set of all polygons. Now what is my relation? My relation is defined from on the polygon. Now what is the relation defined as? R equal to, if I take two polygons P1 and P2, both of them will have same number of sides. So number of sides of P1 equal to number of sides of P2. Number of sides, okay? You did not say sides are equal. You said number of sides of P1 should be equal to number of sides of P2. That means if it is triangle, P1 is a triangle, P2 also must be a triangle. If P1 is a quadrilateral, P2 must be a quadrilateral. Okay. So let's talk about reflexive. For every P1 belongs to set A, you know very well P1 comma P1 will be related. Why? Because number of sides of P1 equal to number of sides of P1. It's a very stupid statement, but just for the sake of writing, I am writing it. P1 comma P1. What is symmetric? For every P1 comma P2 belongs to A, if you have P1 is related to P2, that means what? Number of sides of P1 equal to number of sides of P2. Obviously reverse it. This implies, it's actually boring, number of sides of P2 is equal to number of sides of P1. This shows P2 comma P1 belongs to R, therefore R is symmetric. These are all not so great sums, so they are simple. Okay. Now let's go to transitive. For transitive, I'll choose three polygons P1, P2 and P3. All of them belong to set A. If P1 and P2 belongs to R and P2 and P3 belongs to R, then you can say the number of sides of P1 equal to number of sides of P2, but obviously number of sides of P2 will be equal to number of sides of P3, that is given. So from this what you can say, number of sides of P1 equal to number of sides of P3. So P1 comma P3 belongs to R. Therefore, what type of relation is R? R is transitive. Now that you know R is reflexive, symmetric and transitive, R is what relation? R is an equivalence relation. Okay, but there is one more subdivision to this. What is set of all elements in A related to a right-angled triangle 3, 4, 5? So I have a triangle whose sides are 3, 4, 5. Well, I don't care about the measurement. You know, a triangle has 3 sides. So all the polygons, so P1 related to T, okay, should be what? Number of sides of P1 equal to number of sides of the triangle given. What is the number of sides of the triangle given? 3. So the answer is set of all triangles in A. You take all triangles because the number of sides should be 3. So number of sides is 3 means it has to be a triangle. So you don't take any polygon, but you take polygon with 3 sides, which will satisfy this particular relation. So we are actually talking about equivalence clause. Okay. So you know what equivalence clause is? Separating the set into small parts. Here I break this into small part. What is this? What is one part here? I am collecting. If I have set of all polygons, I am breaking the set into triangles. Later on you will have maybe quadrilateral. Then you will have 5-sided figure. You may have 6-sided figure and so on. But I am collecting all the triangles which will satisfy this condition. Okay, all triangles, because he has given you a triangle T with sides 3, 4, 5. But I am not interested in the side 3, 4, 5. It has 3 sides. So what is all polygons with 3 sides in A? It is set of all triangles. That's all. The answer is set of all triangles. I hope it's clear. Now let's go to the next question. Now this is actually a very nice problem. Already you know this. We can discuss this quickly. Now I have my set L. What is that? Straight line in a plane. That is very important. If it is in space, it gets complicated. Okay, it's a straight line in plane. And what is my relation? My relation is, if I have two lines L1 and L2, then they are parallel. Okay, let's talk about reflexive. If I choose L1 belongs to A, belongs to L, you know every line is parallel to itself, right? So clearly L1 comma L1 belongs to R. So what type of relation is R? R is reflexive. Let's go to symmetric. It's very, very simple, so we can just go fast. For every L1 comma L2 belongs to L, if L1 comma L2 belongs to R, that means what do you know? L1 is parallel to L2. Obviously, L2 will be parallel to L1. If L2 is parallel to L1, you know L2 comma L1 belongs to R. Therefore, R is symmetric. Now let's go to transitive. For every L1 comma L2 comma L3 belongs to L, if L1 is related to L2 and L2 is related to L3, what do you know? L1 is parallel to L2, L2 is parallel to L3. This implies L1 is parallel to L3, which means L1 comma L3 belongs to R. Therefore, what type of relation R is? R is transitive. So you have proved that R is reflexive, symmetric and transitive. So what type of relation is R? R is an equivalence relation. Now you have to find the equivalence clause. What is the equivalence clause? Set of all lines related to y equal to 2x plus 4. So what is the slope of this line? Y equal to mx plus c. Therefore the slope of this is of the form y equal to mx plus c. So obviously my slope is 2. So the relation is parallel to. So I should collect all lines that are parallel to this. What is that? Y equal to 2x plus k, where k belongs to real numbers. Set of all lines parallel to y equal to 2x plus 4. So what is set of all lines parallel to y equal to 2x plus 4? Y equal to 2x plus k, because y and x will determine the slope. They will differ only by the constant. So the set of all lines parallel to y equal to 2x plus 4 will be y equal to 2x plus k, where k is any arbitrary real number. Okay. So with that, we'll stop with the class. I hope you understand these problems. They are not difficult. In the next class, these are all questions taken from NCERT. And in the next video, I'm going to put problems from outside NCERT, which has come in the board exam. They're very, very important type of questions and little difficult and lengthy also. So kindly subscribe to my channel and also click the bell icon to get notifications of all videos. And thank you for your support. I hope these videos are very useful to you. Okay, make sure you practice every day, and so that you do better in your exam. Okay, thank you very much. See you again in the next class. Bye bye.